Hi dear students, let's see this question that came in JEE Advanced Paper 1 Physics in the year 2018. One of the easiest questions of the paper. Again, most of the students would have done this question without any problem. It was a no-brainer. The question was from the topic of, you can say, rotation plus kinematics. Uh, so let's see what's happening over here. This is a body of mass 1 kg, which is at origin at rest at time 0. So there's a force which is given which is of the magnitude alpha t I cap plus beta j cap is applied on the body, and alpha and beta are 1 1. So I don't know why they, like, I guess they're trying to make it complex, but they could have simply said that force is t I cap plus j cap. So alpha and beta anyway are 1. So we have to talk about the torque acting on the body about the origin at time t. E so here it will be equals to 1 second is tau. Okay, so torque at the time 1 second is tau. Which of the following statements is correct? So basically, we have to compute the magnitude of the torque at 1 second. We have to talk about the direction of the torque. We have to compute about the velocity and the displacement all at 1 second. So let's do this question very simple. You can see that force is mass of the body is also 1. So basically, using F equals to ma, force has been given as alpha t I cap. So alpha is 1, t I cap plus beta is 1, j cap. This will be equals to mass into acceleration. Acceleration we can write as dv by dt. Okay, so we can do the vector integration over here. dv is equals to t dt I cap plus j cap into dt. Since initially the particle was at rest, so we can say that velocity will be 0 at time 0, and velocity, let us say, it becomes v at time t, right? So we will get this as t square by 2 I cap plus j cap into t, right? So now we have to find the since we have to compute the torque at time 1 second, so we will also need the position of the particle. You can see that we have to find the torque about the origin at time 1 second. So let's calculate the position. So we can write this as dr by dt, and then you can take dt on the right side. So this will become t square by 2 dt I cap plus j cap t into dt. Okay, and then you can integrate it. At time 0, we can say that position was 0 because the particle was at origin, and at time t, the, let's say, position becomes r. So this will become r vector is equals to t cube by 6. Okay, I cap plus this will become t square by 2 j cap, right? T square by 2 j cap. Yeah, so now we can do the check the options. First, let's compute the torque. So torque is, we know, r cross f. So at t equals to 1, the value of the r is 1 by 6 I cap plus 1 by 2 j cap. 1 by 6 I cap plus 1 by 2 j cap will be cross product with force. Force at t equals to 1 is I cap plus j cap, right? So if you do the maths, so I cross I is 0, I cross j is k. So that will become 1 by 6 k cap. J cross I is minus k, so that will become minus half k cap, and j cross j will be 0. So what will this become? 1 by 6 minus 3 by 6, so minus 2 by 6. So that means minus 1 by 3 k cap. This will be the value of the torque. So if you go back to options, mod of torque is 1 by 3, which is correct. Direction of torque is not plus k cap because it is negative. So option B is wrong, right? Velocity, we can see velocity function was this. So velocity is half I cap plus j cap if you put t equals to 1. So half I cap plus j cap is what they have given. So this is right. The magnitude of the displacement at t equals to 1 is 1 by 6. So since the particle was at origin at time 0, so the position vector itself will become displacement. And if you put position, like if you check the position at time 1, this is 1 by 6 I cap plus 1 by 2 j cap. Clearly the magnitude will be more than 1 by 6. You can see that under root of 1 by 6 square plus half square will be more than 1 by 6. Hence this is wrong. So correct answer will be A and C. So again, this was a very easy question, and as you can see, almost everyone would have done this correctly barring any calculation error. That's it. Thank you.